All right, folks. In this video, we are going to talk through how to wire our CompactLogix or CompactLogix or our ControlLogix PLC. And, I say that, but we're actually going to talk through a lot of basics of wiring a PLC. So this probably goes for all Allen Bradley PLCs, all Siemens PLCs. Because, recently I had an instructor in my class, and, that's something she really brought to light is, we do a good job of showing how to wire a PLC, but sometimes how do we take someone's wiring that is incorrect and figure out what's wrong with it without tearing it all down? So actually, I'm going to walk through this the way I see a lot of you try to wire yours. And we're going to talk through how to wire it the correct way also. Now, if you're following along on this, then if we go to twcontrols.com, and we go to the online courses, and then Studio 5000, RSLogix 5000 for the ControlLogix and CompactLogix PLC. And right now what we're building out is this comprehensive guide to learning PLCs. So this we did last year for the connected components of Micro 800 PLC, and y'all really liked it. So this is what we're going to do for the Studio 5000 now. So these are really long burns through specific topics. So in our last one, we went through how to select their proper version of Studio 5000, and now we're going to talk through wiring it. And if you have one of our trainers, then you know about this already, but so we have twcontrols.com/getting started guide. And so this talks a little bit through, getting our trainer out and getting familiar with the components. And then we have the sample programs, which I have that sample program for this one open, and we'll touch on it a little bit in this video. And then we have wiring enough to get started. And this is the actual wiring diagram that we're going to go through ultimately. But we're going to talk through several aspects of it. So right here, this is the 5069 wiring, which if you look, it doesn't look that much different than the regular CompactLogix wiring, which doesn't look that much different than the Micro 850 wiring. So these principles that we're going to talk about today will transfer from PLC to PLC. And so what I want to do is I want to go through how we kind of do it in our training class. And probably the way you're even thinking about it now is, I start off asking them, okay, well, I need to wire this button here. First of all, is it an input or is it an output? And, sometimes it can be difficult to make sure we understand what an input is and what an output is. But inputs are things we're going to read, things we're going to gather, where we're going to gather information about the machine. Outputs is how we make action happen. So all of your buttons, your switches, those are going to be inputs. Your lights, this relay coil, the coil part, that's going to be an output. Now, we also have contacts going off of this that may go back to an input to make sure it turns on. But we're going to start with the button. So first of all, if you have one of our trainers, it comes with a pack of wire. And I always ask you, okay, well, all right, how are we going to do this? And, every group, it's almost universal. They're really excited to hook up a wire, when they're like, oh, yeah, well, let's go ahead and hook up the one we know. So we grab a wire. First of all, we turn our trainer off. And everybody knows, okay, we want to hook the green button up. And I'll say, all right, I want to hook the green button up to input 0 over here. And I'm going to want to normally open contacts. So a little bit about contacts and what that means. So on our contacts, you can't quite see into these, but there is a green contact and there's a red contact. And they also say NO for normally open, NC for normally closed. And so your normally open contacts are not normally touching. They're normally open. And when you press the button, the two wires will come together from the top to the bottom. The normally closed, they are normally touching. And when you press the button, it's going to break them. So we're going to do a normally open. And I'm going to take one wire into the bottom of it. And then I'm going to take this to input 0. And really cool part about the 5069s and the RA5000s is they are push connects, and the wire goes on the left side. So I'm going to press in, and that wire is connected. Everybody gets this part perfectly. And here's where some of you kind of get stumped, because now you feel, well, I've got a wire connected here, and when I press it, it should do something. Now, there's something that I ask all the time in my class, and I really want y'all to think through this when you're having trouble with your circuits, is ask yourself, do you have current? Now, in order for us to have current, we have to have a path from the plus of our 24-volt power supply through some type of load and back to the minus. That's what it takes to have current. And so right now we have one wire hanging here, and yeah, we definitely do not have current. So then I'm usually like, okay, well, what needs to go to the top of it? And out of 8 technicians, usually 5 or 6 of them will know. They'll be like, well, we need to put plus 24 volt there. Actually, first they say, well, we need to put voltage there. And I'm like, what type of voltage? They're like, well, DC voltage. I'm like, what type of DC voltage? And they'll be like, plus 24 volt DC voltage. Or they'll just see 24 volt DC voltage. And I'm like, well, what type of 24 volt DC voltage? And usually they get stumped at that point. And finally, I'm like, well, I have 2 wires on this power supply. I have plus and I have minus. Which one should it be? And they're like, oh, well, the plus. I'm like, well, how do you know it should be the plus? And this is the part that I think most people don't really follow. And I haven't seen a grand explanation. So I'm really looking forward to if anybody happens to have a better explanation than mine. But the question we have to ask ourselves is, are these modules syncing or sourcing? Now, this is one thing. I don't know why Rockwell did this. On most modules up until recently, if you look at this CompactLogix here, oops, I don't have my auto zoom on. I thought I did. Maybe you can read it, maybe you can't, but it says right there, 24 volt sync. And that would tell us that we're having a sync and output input module. They don't say anything here now. You have to know it, or we have to look it up. And so if we look it up, and I'm just going to take our student guide here, and then we'll go all the way to the bottom and just go up a little bit. And this is the excerpt out of that 5069 IB16 module. This is how to wire it. And I think this starts to stump us a lot, just the way this is laid out. But it does say there that this is a syncing input module. So now, what does that exactly mean if, as far as what a syncing module is and what a sourcing module is? Now, very big warning to this. If you watched my other syncing and source video, I kind of stumbled into this in the last one, is some manufacturers treat the term syncing and sourcing opposite of others. So what we're getting to learn here is for Allen Bradley and Siemens PLCs, and may work for your particular PLC as well. But so if we have a sync, and I came up with this when someone was asking me about it one time, and this is the best that I've come up with. So we have a syncing input module, and it says the following diagram could help you wire your input or output. Put your hand over the type of input or output you're wiring. Your hand represents the PLC. What is left is how you wire your circuit. And note, this works for Allen Bradley and Siemens. Some PLC manufacturers swap these terms. So I can't put my hand over this, but I can scroll down so that you can only see that part. And so what that means is we are going to take plus 24 volt up to our button, and then we're going to come on over to our PLC input. And then we have this little itty bitty piece of wire right here. And this is probably the one that stumps people the most. But okay, we know we need plus 24 volt up to them. So I'm going to take another wire. We'll get all these wires out, that we can have a big old mess. And on our trainers, the left set of terminals is your plus 24 volt. The right set here is your minus. This red jumper is jumping them all together. So that means you have 16 plus 24 volts, 4 by 4. And you have 16 minus 24 volts, 4 by 4. So you can put them anywhere on here and it'll be the same thing. So I'm going to press that one into there. And then we'll put that to the top of our power supply. On top of our push button. And so this is where usually we get to. In fact, I say usually we get to so much that I'm going to go ahead and power this trainer up. That way we can see what happens. So one really cool thing about the 5069 is you do not have to wait for the PLC to power up. It is reading these inputs right now. And I press the button and I get no lights. And the question you have to ask yourself is, do you have current? So in order to have current, I have to be able to take positive power through my circuit. So when I press the button, that continues it on to this PLC input. And then it has to get back to the minus. And this is a really entertaining one at the training center a lot of times, because somebody will immediately just shove a wire down here at the bottom and take it to the minus. I'm like, why are you doing that? They're like, well, that needs to be there. I'm like, well, why does it need to be there? And then they try it and they find, oh, that doesn't work. And so here's where I don't think that Rockwell does a great job on this wiring diagram. But if we go back and we look at that wiring diagram, well, there is our DC plus, and here's our DC minus. And we get looking here and we're like, well, we need a 3-wire sensor. I mean, I've got, people with a lot of experience will say this. Well, I need a 3-wire sensor to wire that to finish my circuit. And I'm like, well, wait, input 0 looks like it just has a button on it. Why isn't it not working? And I really think they could do a little bit better on this, but we got to get reading into the words up here. And then so it says in a note up here, these modules use the DC SA power. You must connect DC power to the device that supplies the SA power to the module. And the SA power is right here on the PLC. So it says right there, SA power. And you have 2 pluses, you have 2 minuses, and then you have a ground here. So we need to apply plus 24 volt to our plus SA power and minus 24 volt to our minus SA power. So I'm going to turn the trainer off, grab 2 wires. And I'm going to push 1 wire into terminal number 17, which is the very bottom one. Also, you'll notice I almost did it. The wire goes in the left side. So I'm going to press 1 wire into 17, 1 wire into 16. I'm going to make sure I have the terminal 17 wire, the very bottom one, and we're going to put it into the minus set of terminals. So anywhere on this right set of gray blocks. And then we're going to take the one that's the 16, and we're going to connect it to the left set of terminal blocks, which is our plus 24 volt. So that's going to put power on our SA power. Now, the one thing to check for, in fact, I'm going to take one of those wires back off because I should have pointed that out. So I got 1 wire of it now. And now if I plug it in, notice the SA power light is off right now. And that's a key indicator that, we need to check the SA power. So I'm going to power it back off. I'm going to put the SA plus. Whoops, I unhooked the wrong wire. I put these wires in the wrong place. Hey. Oh, well, if you're watching, you're doing exactly what I'm doing. Well, you see how we end up fumbling through this. I sat there and told you, put them over here. What did I do? I put them over here. So now I have the wires hooked up properly. I didn't even need to do that little SA power spill, because now when we power it up, we have no SA power. But here's what the older school electricians will do too. They're like, well, I know I need something down there. I'm like, well, what is something? So these wires needed to go over here. We needed to get an SA power light on right here. And since I landed them in the wrong spot, we didn't get that. So I'm going to take this turbo number 16 wire out. And yeah, it goes over here to SA plus. Now be really careful when you're doing this. Notice you have 2 pluses and then 2 minuses. So if you get in a hurry and you put this in the next one down, you're going to dead short the PLC out, or actually your power supply, not the PLC. So this will go in either the third or the plus goes in the first or the second one, and the minus goes in the third and fourth one, or fourth. And now we're powered up. We immediately get our SA plus, and we press our button, and now we're getting our input 0 light. Okay, now let's kind of look at where that puts us at on our wiring enough to get started guide. So if we come up here, then from the factory, your MP plus is already wired. That powers up your PLC. And then we just discovered we needed this SA plus and this SA minus. And this ground is already wired. And then on our input side, we just wired input 0. And now we need to wire the rest of these. Now, let's look a little bit about how we could do this. So one, we could simply go from the plus to the top of button 2, from the plus to the top of button 3, from the plus to the top of button 4. But typically, you're going to see these wires jumpered across here. So current doesn't really care if it goes from here directly to this button, or if it goes from here to a wire that's also landed to here to the one that's also landed to here. So typically you would see these jumpered straight across. And, on your trainer, if you're going to leave your wires permanent, then you could cut these short. Now, honestly, on most of our trainers in the training center, we wire and unwire every week. So we don't do a lot of it. But so I'm going to power it off. And I'm going to put a second wire, give us a little zoom here. I'm going to put a second wire in along with button 1's top one that's going to the plus 24 volt over here. I'm going to put another wire right in along with it. And then I'm going to take that wire and another wire, and we're going to put both of those wires into button 2. So that's going to give the top of button 2 power. And then we'll take another wire and that wire. We're going to put it into button 3. And then we'll take that wire and another wire, and we'll take it to button 4. And then for to switch 1. Well, a contact is a contact is a contact as far as PLCs go. Oops, let me just bring that down just a little bit. That way you can see what I'm pointing at really well. But yeah, so this button contact and this switch contact are exactly the same thing. Electrons don't care, so we're just going to take this. We're going to connect it right on to switch 1. And then we'll take it and another wire right on to switch 2. Oops. I got ahead of myself. I grabbed 2 wires and shoved it in there. We're taking this wire and this wire right on to switch 2. Okay, now notice switch 3 has 2 contacts. We just keep jumping right across, just like normal. So we're just going to take, oh man, what did I do? Okay, well, apparently I need help even following wires here. So I took, whoops, that wire's wrong. Took a wire from here to here. This wire, there you go. I got to check mine right on the live stream. You'll have to check yours too. And nothing wrong. If it's not a big deal if yours doesn't work the first time. So that one goes there. And then this wire should have gone right here. And then we continue on to switch 2. Then we'll continue on to switch 3. And yeah, in switch 3's case, notice we have 2 contacts. We'll figure out our left and right in a little bit, but for now, we're just jumping straight across. Put that one into there, and then we'll grab another wire. And we'll connect it right to switch the other side of switch 3. And then we'll take one more wire. And we're going to connect it to the other side of switch 4. So in essence, all we've done is jumper all the normally open contacts across the top of our buttons. Now, one thing that I do recommend doing this when you're building panels, and honestly, this is probably a good idea for where you right now, is let's mark off what we've actually done. And I'll show you an easy way that we can do it from our screen. Whoops. Well, I'm sorry. I just realized I wasn't even over on the chat. Daniel, good to see you. I have a question. It can wait until you're done. The information on your trainer when connecting a 525 drive. How are you converting 110 volt to run the motor? Well, this is a 110 volt rated PowerFlex 525, so you can't actually put 230 volt on it. So it's 110 volt in, 230 volt three phase. Hey, Jeff Kuiper. Yeah, the 0 volt gets us every single time. Oh, Jeff already answered the question too. So yeah. There are a couple of models of PowerFlex 525s that can take 120 volt. I think it's a half horsepower and a 3 horsepower. Jeff probably knows also. Might be a 1 horsepower. I think it's just a half and 3/4 though. Okay, so let's go ahead and let's see what we've got here. On our diagram, what I'm going to do is we're going to go here and I'm just going to go snip and we're going to go open a snipping tool. Just so we can kind of make sure we're following along. And honestly, normally I would have a print, I guess I'm old. I would have a printed out piece of paper probably to do this on, but we're just going to grab this diagram and then we have a highlighter up here. And I would normally take a highlighter. I would highlight things as I do them. So from the factory, your plus MP24 was wired. Your minus MP24 was wired. We looked at our IV16 module and we figured out that we needed the SA plus, the SA minus, and then this is wired from the factory. And we had wired button 1, and then we figured out that we had syncing inputs, so we needed plus 24 volt here. And now what we've done is I'll put this jumper in across here that is really, see how good my art skills are, is really getting us down to here. So we have just ran a jumper right across all of these. And so next we need to wire the input side of this. Also notice we have the normally open. I wanted to pop that off and show a little bit on it first. But let's go ahead and hook up the other side of all of our wires. So one thing that's taken me so long, and I should have done this, and it's only a big deal the first time, because I went ahead and grabbed a factory set of wires that come with your trainer, and the wires are cut and stripped, and you just have to take your fingernail and pop them off. But I was doing that on everyone, so I'm going to sit here and just pop these off. See, I need more than that there. At least get a few of them going here. Okay. So power's off to our trainer. So now we're going to start on the bottom. And I'm not even going to hook to the other side. I'm just going to start hooking up the opposite side of what you have wired. Now, I didn't really point this out. One other thing that I see sometimes people do is they want to connect here and here. Or sometimes they want to connect here and here across. Let me zoom in a little bit, make sure y'all can see that. So they'll want to take one wire here and one wire here and think the current's going to flow through there. Or sometimes they want to take one wire here and one wire here. And I think these switches over here show it really well. The contacts are on the left side and right side. So there is no internal connection between your left contact and your right contact. In fact, let me just take this off, that way you can see it. So if I unscrew this normally closed contact, yeah, there's absolutely nothing here actually connecting it in any way. So it's just a mechanical button doing that. Pop that back on. And now I'm going to take and just put a wire on the bottom of pretty much every contact that I put a wire on the top of. One there. there. All right, 4 more wires. 2, 3, 4. And we're going to pop the other side of these off. Look those up. Over on this. All right, now let's make one clarification mainly on switch 3 and switch 4. So if you notice on switch 3, input 6 goes to one contact, input 7 goes to the other contact. Now, the way these are set up in all of our videos is so that if you're looking at the front of the trainer, if you turn switch 3 to the left, that is input 6. If you turn switch 3 to the right, that is input 7. And the same with switch 4. Now, here's what gets people confused is if we look at the back of the switch, and if I can zoom in and get just enough focus on it, is I'm turning it to the left right now. As you're looking at the back of the trainer, that is the right contact. Now, in the end, they're actually going to go in order. So this was input 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the order we're going to put them in. So now we'll just grab button 2. And yes, button 2 goes to input 1. Sometimes that bugs people, but when we get to switch 1, we're going to start over 2. It's all good. Oops, and even then I put it in the wrong spot. There we go. And then button 3 goes to input 2. Button 4, we go to input 3. And then we have switch 1. That's going to go to input 4. We have switch 2. That goes to input 5. And then on switch 3, we want as we're looking at the back of it, the right contact, which is going to move when we switch it to the left on the front. That's 6. And then the other one is going to be 7. And then the right, as you're looking at the back of it, is going to be 8 of switch 4. And then input 9. All right, that gets us all the way to our relay. And so for our relay has 2 basic parts. We have the contacts and we have the coil. And we're going to go through a lot of relay videos later on. We want to get this wire just enough that way we can make sure that everything works on your trainer and that you understand the basic wiring. So if we go back over here and we go, let's use the student guide. Right here, there is a blow up of the relay. And so the coil, the part that actually energizes the relay or the output from the PLC is going to be A1 and A2. Our inputs, those are the contacts that move. So we have the 11, 14, 12 arrangement, and we have the 41, 44, 42 arrangement. So on this, it's telling us 11 needs to go to plus 24 volt, and then 14 needs to go to input 10. So there's your 11. And so normally closed, normally touching, you can just take and trace it out. Normally touching is 12. Normally open or normally not touching, that's 14. So this is going to be our plus 24 volt, and this will be our input. And if we look on our relay, then you can actually see the numbers, and very nicely it also tells us which one is which right there. Let me just pop that off so you can see it a little closer. So yeah, and I don't know if the gray on gray is really going to show up on this, but yeah, here's where, really be great if y'all could see that a little bit. Should have taken a picture of this. Let's see, throw a little light on. Oh, can't throw a light on it. Yeah, this is gonna be crude. I don't think it's gonna show up good. Yeah, it's the only thing I don't like about the gray on gray. It's like, all right, think it's there, but yeah. So anyway, 11 is the back one right here, and 14 is going to be your middle one right here. So this is your common, this is your normally open, and this is your normally closed. So pop that back on. And then we'll take another wire. Now we could, we talked about these jumpers, we could jumper from up here down to here, but this is a situation where it makes a lot more sense just to put this wire back onto our terminal block. And we're going to take another wire into the left set of terminals over here. Any open spot will work. If you're full of spots down here, you can stick it up here. It's perfectly fine as long as you're on this one with this red jumper. And we're going to take that and put it on 11. And then we'll take another wire. Whoops, you couldn't see me do that. I'll put that right here on 11, the back row, the right-hand one. And then we're going to take another wire on 14, which is the middle row, the right-hand one. And we're going to take it to number 10, the next input down. So really that fills up our inputs. You should have no missing spaces. And we're going to go ahead and turn this trainer on now and see what it does. Now, while that's powering up, let's just take a quick recap on our highlighter here. So we just finished wiring really all of these inputs right through here. Some really bad straight lines, but you get the point. And then we wired the contact portion of our relay. And that's that right there. And so now we need to test our inputs. And don't just get excited that a light lights up and move on. Make sure it's the right light. This might be one of my this could be the number one frustration I have in the class is every class week, and think about this, as you're starting to do projects, I ask them, if we're doing a project and we're scheduling some downtime, how important is it that we make sure everything works before that downtime is scheduled? And they're all like, yeah, really important. And I'm like, okay, so should we just get excited when we see a light up, or should we make sure it's the right light? And they're all like, oh yeah, let's make sure it's the right light. Out of the 8 technicians, I promise you 4 of them will have something wrong a few days later. And think about that next week, or when I say next week is when you're back at the plant. I guess it doesn't make a lot of sense for this live stream. But if you just get in a hurry and you're just like, yeah, something lit up, I'm sure it's right. And now we're in the startup and commissioning phase where we have all the operators there. We probably have the plant management there. We have quality there, and we're dealing with real money. How quickly can that really burn through cash just because we didn't check that we had the right input operating? So when I say the right one, we want to make sure that what we wired on this list matches what we're seeing on these lights. So I press button 1 and input 0 lights up. I press button 2, input 1 lights up. I press button 3, input 2 lights up. I press button 4, input 3 lights up. Now switch 1, it is the switch. So to the left it is off. To the right, input 4 lights up. Switch 2 the same way. To the right, input 5 lights up. Switch 3. Oh, yeah, I didn't think about that. You may get startled there. I should have warned you. Switch 2, when you do turn it to the right, that does turn your PowerFlex 525 on for the Getting Started program. So that also worked. Then switch 3, very important. This is the one that usually gets everybody. When we turn it to the left, as we're looking at the front of the trainer, when I say the front of the trainer, that means if we're looking here, if I get that all the way around with the cord, I need a longer cord on this trainer. This is left. This way is left. And so you want to make sure when you turn it to the left, that input 6 lights up. When we turn it to the right, input 7 lights up. Switch 3 to the left, input 8 lights up. To the right, input 9 lights up. And then we have the relay contact. Now, first you're going to think, well, I can't check the relay contact, but we have a switch right here. And this lever right here will override that relay and mechanically make that move. And there's input 10. So now we know all our inputs work. And now we're ready to wire our outputs. So let's see, Daniel, what do you got? I understand that. My question is more on the power requirement for the drive. I'm guessing you would need to set the drive up for, no, Daniel, I mean, literally. You pull the thing out of the box, you put 120 volt to it, you hit the green button on the front of the drive. Now, if you're buying our trainer, we configured so it'll run off the PLC out of the box, but we factory reset. Now I can do it near the end of the video. No, all you gotta do is hit the green button on the drive and it puts out 233 phasers. This is, I mean, that's what I love about this drive. I mean, no, there's no configurations, no thinking. There's no anything, really. It'll just run. Okay, so but yeah, I'll demo that at the end if you want. Now, this is a 3-phase motor also. Maybe that's where your confusion's at. No, this is a 3-phase motor, and yeah, you want, typically all variable frequency drives go to 3-phase motors, with the exception of one particular well pump that I used to work with a lot, just because you're in a rural area and they did need usually hefty power. Okay, let's get back to this. So our next thing we got to do is we have to wire our outputs. Now, we get more struggles on people wiring their outputs than, inputs. Now, the common's the one that gets the inputs, where, we forget that 0 volt, the the SA minus, and we get discouraged on that. The outputs have a lot of interesting learning opportunities along the way that we should talk about. So first of all, what type of outputs do we have? And here's where, I really kind of appreciate, the CompactLogix, because it tells us right there. It's a 24 volt source output. Well, this one right here doesn't tell me anything, so we have to look it up. And so if we go to the instruction for it, then here is the OB16, and it says it's a sourcing output module. And they do a semi-okay job of showing part of this, except there's an LA plus floating in midair here that you have to assume is the LA plus here. And yeah, I say they do an okay job. All right, if we go up to our thing here, it says, put your hand over the type of PLC input or output you're wiring. Your hand represents the PLC. What is left is how you wire your circuit. So we have a sourcing output. So I'll scroll down to represent my hand. That means somehow we need to feed plus 24 volt to this. And then we need to take our output to our load. And when I say a load, that could be our light, that could be our relay coil, or that could be a run signal going over to the PowerFlex 525, such as for terminal 2. And then the other side of all of our loads need to go to the minus of our DC power supply. So on this one, just because this is the way I see you do it, usually by that point we figure these jumper things out and we're like, okay, well, I need to jumper all of the minuses together. So let's do that. We're going to turn our trainer off, and we're going to grab 4 wires. All right, 4, 5, some amount of wires. 4, I think. And I'm going to go ahead and pop the insulation off of these. Yeah, Daniel, I think you're, yeah. Okay, yeah, there you go. You said like, yeah. So, literally, that's what I love about these. In fact, sometimes, we're a few, we have a few other drive offerings, and I get so frustrated the amount of configuration you have to do for something that really it should do out of the box. And no, these run right out of the box. But okay, so now what we're going to do is we're going to take a wire, and I'm going to put a wire into the left side. It doesn't matter on these, left or right. In fact, yeah, no, we're going to use the right side. Just so when I'm talking to it, I think I'm more sensitive to what the diagram's showing. So I'm going to put a wire in the right side of light 1. And then I'm going to take that wire and a second wire, and we're going to go into light 2. This is our jumper going across. We'll take that one, and we'll take that one. There we go. We'll tighten them up. And then we'll take that wire and another wire, and we will go in the right side of light 3. Then we'll take that wire and another wire, and we'll go in the right side of light 4. So that's going to connect all the minuses of our light once we take this wire right here and we connect it to the right set of terminals because we need it minus 24 volt go into them. And then usually we're thinking, well, we already did the SA power. We had the plus and minus and the lights on right here, so we should be good to go. And so we're going to grab 4 more wires, and I'll pop the wires off of these as well. Put the wires off of these, the insulation off of these. But remember, of course, this is the only live stream where we'll need to wire them at. But I should have thought to do this before the live stream. And so we're going to take and put 1 wire into the left side of each one of our lights. So go ahead and loosen up all of these. Wire in the left side. And we'll put a wire in the left side of this one. And we'll take a wire in the left side of this one. And finally, we'll put a wire in the left side of this one. All right, then, if we look at our wiring diagram, then output 0 is 1, 1 is 2, 2 is 3, and 3 is 4. So I'm going to take the light 1 wire, and it'll go into output 0. We're going to take the light 2 wire, and it'll go into output 1. We'll take the light 3 wire, it'll go into output 2. And finally, we'll take the light 4 wire, and it'll go into output 3. And usually we think we're done now. So we're going to power the trainer up. And this time we will have to wait for it to power up. Well, yeah, it's Saturday, Daniel. I expect you to be doing something with your family. I would too, but Michael's down here with me today. And then Amber and Wendell are out of town. She's actually looking at her college today. But yeah, so this time we have to wait for it to power up. which you can tell it's fully powered up once you have a solid green run light right over here. But already usually we get discouraged because what do we see when we look at this? But it looks like we have an extremely angry output module right here. And in later videos, we're going to talk about how we can diagnose these through Studio 5000. But when you see this right here, it usually means that you do not have what I would call the common hooked up to this. And in our case, common is the LA plus wire. And we'll talk about how that in a second. Okay, button one's on. To test this, we should press button 1, and we should see output 0 come on right here, and then we should see light 1 come on. Now, we're not even getting output 0, and that's because this thing's flashing like crazy right here. So let's go over and look at the wiring excerpt out of Rumco Automation's instructions, and it kind of shows it down here. We have LA plus and we have LA minus. Now, if I have an old school electrician, they'll tell me, well, this is a sourcing output module, so you don't actually have to connect the LA plus to it. So let's see what happens when we do this. And I gotta be honest, I don't know if I've accidentally done this on this particular setup, so I have no idea what's going to happen. But what we're going to do is we're going to take one wire and make sure you're on the right-hand module. We're going to press it into number 16, which is our LA plus wire. Oops, and we're going to go into that left-hand window. And then we're going to push it into our plus 24 volt. And we're going to power that up. So one good thing about the long power up is it does make you think before you make a bunch of changes, since you have to wait every time, which while we're waiting this time, if you've gotten to this point in this video, have you subscribed to our channel? If you haven't, go ahead and hit that subscribe button. And yeah, I think there's a bell you're supposed to tap. I'm really not good at pitching that, I guess. But okay, so we're waiting on a solid green run light. And it appears that our output module is okay right now. So here's where usually I end up getting the call that, hey, I think I've got a bad PLC. Can you send me a replacement part? And I'll ask them, okay, what all have you checked? And here's why. So right now I'm not pressing any buttons. We do have some outputs on down here. Now, we'll talk about what these outputs are near the end of it. These are actually our checks before we're actually shipping this out. But output 0 is not on right now. But if we spin it around, I really got to get a longer cord on this one, folks. Just unplug our Ethernet for now. We're not using it. Oh. There we go. We spin it around, people tell me, well, it looks like I got a bad output module because my lights are on. And okay, are your lights on? Are your lights not on? We could get in a whole argument about that. We'll show in a second they have the exact same voltage. But right now, the green light looks very much on. The blue light looks very much on. That red light kind of looks on, and the yellow light doesn't look on at all, but they are on. So now my next question is, okay, well, check your light. Let's see what we have. And so if we take our meter, which we haven't talked about meters yet, and if you go into the industrial control wiring section, there's a whole section on meters, and Fluke does not pay me anything. But I will tell you, as you're starting out, this T61000 is probably one of the better meters to pick up, mainly because I want to check voltage. I just switch it to voltage. I don't need to know AC. I don't need to know DC. I don't need to know any of that. I just need to know, oh, I'm checking voltage. And then it'll auto detect what you're doing. So now, what do we have on light 1? So if we zoom in a little bit here, and get over where we can see light 1, and I get this meter where you can see it. And if I touch light 1, oh, if I can hold the meter and do everything else I need to do right now. Oh, nope, can't do it all. There we go. We have 8 volt on this. And if we check the yellow light that didn't even look like it was on, we have 8 volt. And the red light has 7 volt. Maybe it's 8 volt. I'm not sure I had it pressed all the way in because I just dropped the leads. I was about to drop them anyway. And we have 8 volt on light 4. And then people get looking and they're like, okay, well, let me check the rest of these. So we go over to our minus. So I can get all this where you can see it. There, we're just going to jam this in. Now be really careful doing this because you're going to have to release it with something in a second. But so yeah, if we check all the way through our outputs, this has 8-volt on it. This is output 4. There's nothing wired to it. 5 has 8-volt. 6 has 8-volt. 7 has 8-volt. 8 has 8-volt. 9 has 8-volt. 10 has 8-volt. Okay, now 11 is actually on. So when I go to 11, I have 24-volt, just like I should. Now 12 does not have anything on it. It is not turned on. It has 8-volt. 13 has 24-volt because it's on. 14 has 8-volt. And 15 has 8-volt. And so immediately people told me this module is bad. This module is not bad. What we need is a slight lesson, which we aren't going to get today, in how these outputs actually work. So these outputs are not actually switches in there that are opening and closing. They are transistors. And transistors kind of are a gate that allow current to flow through. And all gates, whether they're a ginormous gate on a dam at your local power plant, or if they're a transistor gate, they leak. And so that little bit of leakage current has to go somewhere. And that's why we have to have the minus hooked up on our output module, because that's where the leakage current normally goes. Now, if you don't hook up that, where's the leakage current going to go? But out all of these modules. So just so we can see exactly what this does, and we'll probably do it a couple times just to make sure we get this impact, is I am going to hook this wire up and immediately, oops, well, I got to get the bleed back out of here now. Because I'm going to have this wire hooked up to number 17. I'm going to spin this strainer around where you can see. I'm going to try to spin this strainer around where you can see. And so our lights are definitely glowing right now. And the moment we hook this minus up, they go out to normal. And so we don't actually have these lights on. So even here, and here's what happens too, is we go on through our test. If we press the green button, notice the green kind of gets brighter. Now if we do it with that in, now it's clear on and off. So without that minus, which is right here, this LA minus, that leakage current is just bleeding out of all of this output module right here. So if your lights are slightly glowing, that's going to be the issue. Okay, now we should be ready to test this. So if we go back over here, then, oops, nope, I got a little ahead of myself. We're not quite there yet. So we figured out there's the LA plus wire. And then there's the LA minus wire that I left loose just to show you how they would glow if you accidentally did that. Whoa, that's a crooked line. And then we have done output 0, we've done output 1, we've done output 2, and we've done output 3. That leaves us this relay right here, output 4. And so since these are sourcing output modules, they're putting out the positive power. And if we go up and look at our relay, positive goes to A1. And on these, 100% it does matter. I have some later videos that shows you if you hook these up backwards, they don't work, and you'll actually dead short out your power supply. And depending on what you have, you may blow fuses and all types of other fun stuff. But so for our case, we're going to take output 4 to A1, and we're going to take A2 to the minus of our power supply. And that's going to complete our wiring enough to get started. So we'll spin the strainer back around. We're going to turn our power off. And I'm going to take a wire from output 4. And we're going to take it to A1, which notice A1 is the right-hand coil wire. Don't ask me why it's the right-hand coil wire. Just make sure you look at the numbers and figure out that it's the right-hand coil wire. And then we're going to take a wire from A2 And we're going to take it over to the minus of our power supply. And next I'm going to plug the Ethernet cable back in. Because, yeah, we're going to try to, I need to get this Ethernet cable where it's kind of the same. Yeah, I definitely need a longer cable than this. So we just built this trader. And, yeah, the way we have it arranged now, that cable's short. Okay, so now we're going to power up our trainer. Didn't do that right. So let me just go over there. And then we're going to spin the trader around to the front where you can see it. Now, if we've done everything correctly, also don't get too OCD about your wiring. I mean, really, a good trainer, you'll wire and unwire a lot as you have different setups, as you have different questions, and sometimes just to quiz yourself and make sure you do know this stuff. But yeah, so if we've wired it correctly, the big ones are we press the green button. Oops, I got to wait for the PLC to come on. So before we get excited and do anything, we need a solid run light. Actually, it was just coming on right as I spun that. Now, we press the green button, the green light comes on. Press the yellow button, the yellow light comes on. The blue, the red comes on. The blue, that comes on. Switch 1 actually makes it go through a really basic sequence, and we'll look at it in a second. And then switch 2 will make your VFD run. Now, we're not going to go deep into this getting started program because honestly, don't worry about it too much. Now, if you accidentally, we don't know the difference between download and upload yet, and you accidentally download the program out of your PLC and wipe it out, it's not a big deal. We're not going to really use it much through the rest of the series. But if we were to lose that, then we go to the getting started. This page right here, really bookmark. This is the page that will save you a lot of time. And step 3, drawings and sample programs, you can download the program that was pre-installed as it shipped. So now let's go ahead and go look at the rest of this. We'll just at least get a peek to kind of see what we're going to be getting into throughout the rest of this series. I'm going to go ahead and go online with it. If you don't know how to go online with yours, it's not a huge deal at all, because actually in the next video, that's what we're going to talk about is how to configure our computer to go online. So the first thing we're going to run into is a bunch of JSRs, and mainly we have some different options depending on what you purchase. So almost all of them come with the drive option. They all have the Ethernet switch option. Some of them have an HMI option, some of them have an IO link option, some of them have a motion control option, and there's some custom programs as well. But here's our green button, green light. And so yeah, whenever we press this, that's going and looking for a 1. We mouse over it. That puts a value of 1 in it and makes it true. And a true output energizer is going to go right to 1. And 2 lessons down, that's the main thing we're going to focus on is these instructions right here. And right there is our yellow light. Right there is our red light. And right there is our blue light. Works exactly the same way. And there's where if we turn switch 4, you see this little light timer sequencing. And there's some greater thans and less thans. And we're just doing some basic compares to make those lights light up. All right, let's look at some of the others, because sometimes you'll ask me a question about the other outputs, and really, I'd say you don't even need to worry about them. But let's look. That way we understand what's happening here. And hey, Jeff, if you're still there, actually, here's what you and I were talking about yesterday. This is a really good example that you have you have to be careful of. Actually, I'll break that out to a separate video because I'm going to go ahead and record a couple videos today. But we have a GSV, and this is a get system value. And if we get a class of module, our trainer drive is named trainer drive. If we look down our IO configuration, and about 4 videos from now, we'll be talking about this. In fact, you see there, the LMC has a little microscopic little yellow triangle by it, and the IO link does, and that's because the trainer I grabbed doesn't have either of these options. But we're going to get the entry status. And if 16384 is really our magic number, that means everything is happy. And so then I have an equal 16384, turn on output 11. So output 11 means that your PowerFlex 525 is okay in communicating. So just to show what it would look like, I'm going to take the cover off the front of the PowerFlex 525. Now, first of all, this cover right here, it does not take a jackhammer, pry hard bar, screwdriver, or sledgehammer to take off. There's a little error right here, and that's your release. If you just press down right there, this will pop right off. And then, incredibly carefully, do not accidentally plug back into this DSI port. We want to unplug from Ethernet IP right here. And notice when I unplug from it, this number right here goes off of that 16384 and output 11 drops out. So literally, in fact, before I say that, let me make sure we're going to plug back in that Ethernet IP port, that left-hand port. So all output 11 is to do is mainly when we're building the trainer, we look for output 11 to make sure we have this PowerFlex 525 configured correctly. And then there is switch 2 right there. So switch 2 starts our drive. And about 5 videos in, we'll talk exactly through how this piece works. Okay, on our Ethernet switch, very similarly, is we have that exact same GSV to turn on output 13. And that's just telling us before we ship your trainer that output 13 is good. And then we have an HMI option. This one doesn't have the HMI option. Now, this uses a different one. It can't do the GSV. It does a message instruction. But if yours had an HMI, output 15 would be turned on. That tells us that we have properly configured it before we ship it to you. And then IO link, same thing. We have that GSV. And right now, since this one doesn't have the IO link option, 14 is off. And then finally, we have the LMC. This does not have the LMC option, but if it did, then output 12 would be on. Okay, let me catch up a little bit over here because what our output like a photocoupler. So Carrie, a photocoupler or an optically isolated output is a little bit different than the outputs that we're talking about here. So actually, your PowerFlex 525, because we're gonna this is already on my list because so many people have asked about this, and there's no way I can actually get zoomed in where y'all can see this probably. So you're probably going to have to pop open. Actually, no, I have the manual open. Let me just go ahead and if we look here. Then, did I close it? Nope, still have it open right here. And so an optically isolated output would be something like opto output 1 and opto output 2 on your PowerFlex. And so in this case, you actually do take plus 24 volt to the output, and then it switches it to the minus 24 volts. So that's kind of your optically isolated. These right here, transistors, well, since you asked, I'm sure I can find one. Let's see, transistor diagram. Well, spelled transistor wrong, but I bet it figures it out for me. This is a good one. Actually, no, it doesn't have it in there. So if we look at some of them, and I have a video actually that shows this. This one kind of does. So there's going to be a little bit of bleed. Here's that LA minus wire roughly. So without this wire right here to kind of drain that leakage off, that leakage ends up going out this direction. That's kind of what we're talking about. I don't really get too much into transistors on these items. So, okay, so hopefully that covers all of the issues that you may have ran into while you're wiring your CompactLogix. And also, I didn't push really hard on it, but wiring this CompactLogix is exactly the same. The ControlLogix, actually, it's right on the picture. I can't drag it over, but the ControlLogix, the 1756 IB16D is exactly the same. And, a lot of people ask me, do you have a ControlLogix trainer? Well, there's really nothing you can learn about it. I have one there. We almost never use it because it's just a little bit more pain to wire mainly. But honestly, since we have it sitting here, this Siemens trainer, it's exactly the same. I mean, if you understand syncing and sourcing, you can manage to wire any of these. So our next big obstacle, it's not even our next one, our biggest obstacle 100% every time you walk up to the machine is how do you connect to the PLC? And so that is what we're going to cover next. And so either I will put a playlist here once this live stream is done, or if you go back to twcontrols.com and go into the online courses, you'll see in the comprehensive guide to learning PLCs.